This video demonstrates the use of the Single Complex Builder panel in Schrödinger's Materials Science Suite. This panel allows you to construct a single organometallic complex featuring 1 or 2 metal centers, with geometries ranging from 2 to 9 coordinate systems. Let's dive into the panel's capabilities. The metal and its coordination geometry are chosen in the Define Complex section. In the Specify Ligands section, the quantity and type of ligands for the complex is defined. The total number of occupied coordination sites is displayed at the top. Each ligand is represented by a row, or you can specify the number of copies and load, or sketch the ligand using a dedicated button. Within the Set Ligand and Coordinate Site section, you can select a metal site for coordination with each ligand site. The options in the Build and Save Complex section allows you to build, clean the geometry, and save the 3D structure in the project or in a file. First, I will construct a simple mononuclear complex. ALME2Cl. This trigonal planar monomer has 2 methyl ligands and 1 chloroligand. I will clean its input geometry using XTB during construction. Next, I'll demonstrate options for building dimers with 2 metal centers. Dimers can be constructed with a direct bond between the 2 metal atoms, or with the metal centers bridged by a bidentate ligand, where each of its 2 bonding sites connects to a metal center. First, I'll build a Mn2CO10 dimer, an octahedral dimer with 5 carbonyl ligands on each manganese atom. Next, I'll build a bridged dimer, AU2OAC2Me4. In this structure, the gold atoms are not directly bonded. Instead, they are linked by the bidentate acetato-ligand. This bridged dimer is characterized as a square planar bridged dimer, with acetato serving as the bridging ligand and methyl as the terminal ligand. These complexes can be further optimized using quantum mechanical methods, which allow for the calculation of properties like atomic charges, polarizability, and many more.